Hello guys, today we're going to study 4.1 exponential function. So here we have a definition. The exponential function f with base b is defined by f of x equal to b to the x power or y equal to b to the x power, where our b is a positive constant other than 1. So b has to be greater than 0 and the b cannot be 1, and the x is any real number. We have a b cannot be 1 because 1 to the any power, it just give you 1. So 1 to even this 200 power, then it's still going to give you 1. So example 1 we have here, evaluating a exponential function. So anytime you see the words evaluating, okay, so most likely all you have to do is just plug in your numbers. We have the exponential function f of x equal to 42.2 times 1.56 to the x power models the average amount spent f of x in dollars at a shopping mall after x hours. What is the average amount spent to the nearest dollar after 4 hours? So the model given to you is f of x equal to 42.2 times 1.56 to the x power. Then they're asking you what is after 4 hours. All you have to do is just going to plug this 4 inside your function. So which means it's a 42.2 times 1.56. We're going to replace your x with 4. And then we're going to plug this inside your calculator. It's going to give you around 249.92566. Okay, nearest dollars, that is $250. So that is my final answer. So basically, anytime you talk about the evaluating, pretty much all you have to remember is, oh, okay, so this most likely is going to make me plug in. Let's go ahead and work on example 2. Example 2, I want to graph the exponential function. So we have f of x equal to 2 to the x power. Okay, this is very straightforward. Just thinking about, you're going to have your x, then you're going to have your f of x. So your ordered pair, so basically is your x and y. Let's take a look. Let's plug in a couple points. Okay, we're going to plug in negative 2. So if we're going to plug in negative 2, we're just going to evaluating, which is plugging your negative 2 to your function. So that will be equal to 2 times the negative 2 power. So we have some students struggle on this. If you can recall what you have learned in the past, we have a to the negative n power. That's just going to be 1 over a to the n power. Okay, if you forgot, so this is the formula. So let's go back here. So which means in 2 to the negative 2, that is just going to be 1 over 2 to the second power, which in this case, that will be 1 over 4. Okay, so we have an ordered pair that will be negative 2, 1 over 4. So let's go ahead plug in other points. Negative 1, f of negative 1, remember that's just a 2 to the negative 1 power. There's a whole thing will give me 1 over 2 to the negative 1, that will become positive 1. So this is going to be 1 over 2. So that will be negative 1. The pair is just going to be negative 1 and then 1/2. So you do the same thing for the rest. So let's go ahead and plug in the points. That will be negative 2. So negative 2 and then 1/4. This is around here somewhere. Okay, I'm going to plug in these points inside here. And then we also have negative 1 and then half. This is around here somewhere. And then we also have, right, 0, 1. We have 1, 2. And then we also have 2, 4. 2, 4 is around here somewhere. So once we have these 5 points, you realize it looks like a curve, correct? Okay, so that is your exponential function. Remember, you have to show your work on your tests and quizzes. Okay, example 3. This is another exponential function. So this time we're going to have a g of x equal to 1/2 to the x power. So again, we're going to make this a chart. So we're going to make x. So we're going to have a g of x. And then we're also going to, in the end, write an ordered pair. So let's go ahead and do this. Plug in a couple points. So you can do pretty much the similar stuff. So I'm going to plug in a couple points. I'm going to plug in negative 3 and negative 2, negative 1 and 0 and 1 and see what happens right here. Maybe 1, 2, 3. G of negative 3 is just going to be 1 to the second power, and then this is going to be negative third power. If we have a to the negative nth power, we're going to have a 1 over a to the positive n power, right? So in this case, we have to look at our a. Our a actually just going to be 1/2, right? Maybe we'll write it below it. Hopefully that will help you a little bit. Look at this, okay? What's our a? This whole thing is our a, right? So then we're going to simplify this. That will be 1 over, so when we said that a is 1/2, right? And then to the nth power, the negative 3 become positive 3, right? That will be 1 over, this is going to be 1/8 power. 1 divided by 1/8, just going to be 1 multiply. The reciprocal is 8 over 1. This whole thing give you 8. Okay, so I'm just going to copy it down this side. So this whole thing going to give you 8. We're going to have negative 3 and 8. So then I'll do the next. That g to the negative 2 power. The whole thing actually going to end up with 4. Okay, you can do it step by step, guys. So I didn't need to plug in that many points actually for this graph. All rest of the stuff we're going to plug in the points. Okay, we're going to connect them. Okay, again, I'm going to try my best. Okay, so that is not bad. Again, you can't just do a graph without any words. Okay, so make sure you practice how to evaluate this. Okay, let's go ahead and go next. Alright, so here we have characteristics of exponential function of the form f of x equal to b to the x power. So we have the domain. So when we talk about domain, we're talking about from the left and right. If you look at these two graphs, the domain always is all the real numbers. Okay, that's why you're going to have a domain right here says negative to positive. The range, we're going to talk about up down. So basically our y. The range, this is the range. Okay, and then our domain right there is negative infinity, positive infinity. The second is the graph of all exponential function of the form, okay, b to the x power passes through the point 0, 1. This is very important. Always pass 0 and 1. And because the b to the 0 power is just going to be 1. The b cannot be 0. If we have this base 2 to the 0th power give you 1, and 3 in the 0th power also give you 1. If you think like 234, 0th power always give you 1. That's why you're always going to pass 0, 1. This point. If b is greater than 1, our graph is going to look like a climb the mountain. Okay, if you can think this is just like climb the mountain going higher. And then if we say b is between 0 and 1, this is like a slide going down. Okay, this is red color right here. We're talking about this piece. That's basically we're talking about sliding down, right? Going down. So that's something you need to remember. If you go back and look at the graph really quick, the example 2, our b is 2, is greater than 1. So our graph in the end, see, is going up, right? And then if you look at this, when our base b is 1/2, which is between 0 and 1, our graph is going down. Then number 5, we have f of x equal to b to the x is a 1 to 1 and has an inverse that is a function when our b is greater than 1. This graph, right? So we say this is a 1-to-1 function. That means when we do a horizontal line test, okay, we can't pass more than 1 point. That is the 1-to-1 function. This is what we call it 1-to-1 function. Alright, and then number 6, the graph of f of x equal to b to the x approaches but does not touch the x-axis. This get closer to x-axis but never gonna touch it. We call this, we say y equals 0 is the horizontal asymptote. Okay, here we also have a table. The table is talk about the transformation involving with exponential function. This seems very complicated. Okay, if you look at each piece, so if you look at this, it's a b to the x. You have to think that is a function. b to the x and plus c or minus c. We learned this before. We learned about a function, just a regular function, not the exponential function. But the concept is exactly the same. F of x plus c. Alright, c is outside, and that is up c units. Then if you subtract c, that's down c units. Okay, then you look at the second one right here. We have a horizontal translation. When we talk about horizontal translation, okay, this is c is inside your function, and then if it's a plus c, we're gonna say the left side c units, and then it's a minus c, we say the right c unit. If you look at this, it's exactly the same. And then the next is reflection. Reflections outside negative f of x, then that's just going to be reflecting about the x-axis. Just think about that is a lake, that blue color. Okay, so that's a reflects about the x-axis. and then reflect the graph about the y-axis. So basically you're going to have the negative x is inside your function. So that basically that will be b to the negative x power. So then let's look at the next, the vertical stretching or shrinking. So you can read those, okay? Verticals, you know, those stretching and shrinking, we all did this before. Example 4, transformation involving exponential function. So use the graph of f of x equal to 3 to the x power to obtain the graph of g of x equal to 3 to the x plus 1 power. And then I also ask what is the horizontal asymptote in this case. Okay, first let's look. This is x plus 1. Okay, thinking this is inside your function, right? So if you want to, until you're used to it, you can go to match it. So if you look at this, that is the case 2, right? So we're talking about this right here, case 2 right here. So which means we say this is a shift f of x to, in this case that will be to left 1 unit. We're going to shift all the points left 1 unit. So this 1 unit, here we have right there, and then we also have this point, and then right here. So that is what we have. So then we're going to just connect those points. Okay, so that is we shifted 1 unit. Okay, so left. We're going to label the graph. Example 5, use the graph f of x equals to 2 to the x power to obtain the graph g of x equal to 2 to the x power minus 3. And then if you look at this question, this is the form we talk about. This is c is outside. So this is the form b to the x minus c. So then we look at this, we say, okay, so the c is outside. All we have to say is shift down 3 units. So let's go ahead and shift this down 3 units. So let's go ahead and use this. Let's use the purple, and then I'm just going to graph it. Okay, so we can call this as g of x equal to 2 to the x minus 3. Okay, so I forgot to answer the question early. So what is the horizontal asymptote in this case? Okay, so if you look, we move down the 3 units. So this is our horizontal asymptote, which is y equals negative 3. Okay, so let's go back to look at the question above. So in this case, what was the horizontal asymptote? We only to move to the left in this case. So basically, we're still going to have this piece right there. Y equals 0 is the horizontal asymptote. Alright, that is the part I forgot. Anyway, if the graph given to you, right? So what we're talking about, if they gave to you this, alright, you don't have to graph it. And all you have to do is just shifting down or up. However, if this is not given to you, I need you to graph that first. That's what we did for example 2 and 3. Okay, you know how to graph them. Example 6, select a function for the graph. So here given to your graph, I want you to guess which one is your function. So you have to use your knowledge, alright? We have to think what is the basic graph look like. So I know the original graph. Okay, if I want to graph something, this is my, let's say this is my g of x. Okay, basic graph, 2 to the x power, right? And then the path is 1, 0, 1, right there. So now we're going to have the graph here, okay, on the left side. If you think about it, this is the reflection, right? This actually reflect here, because if we did a reflection from your basic function, you're going to have something like this. So your reflection was the x-axis, right? Because this is negative 0, negative 1. In that case, we're going to have something like here. Okay? Again, go back to look at your chart. The reflection right there. That is when we have the reflection about the x-axis right there. Okay? That's why. So this is our answer. Okay? Alright, then look at the example 7. Here we have a select function for the graph again. So now you look. So this is our original graph, okay? So because the 2 is greater than 1, so we know this graph should have something like this. Okay, and then path is 0 and 1. This is my basic graph. And then now it's not passing this 1 anymore. In fact, we're passing this 1, 1 right here. And then you have to think, okay, I no longer pass this. And then everything else stay the same. All I have to think is I actually, if you think right here, I actually move this to the right side, 1 unit. The only one here is actually B. If you look at your A, you're going to have a x-axis reflection. You also have a y-axis reflection right here in there. If you look at the C, that's the original graph, and then D is a reflection about x-axis, so B is our answer. Okay, the next is natural base e. You don't have to think too deep about this. Just remember, f of x is equal to e to the x power is called a natural exponential function. So around the 2.7. And then the horizontal asymptote is the same as y equals to 0. Let's see how we use a natural exponential function. So here we have an application question. You can pause this video and read it. So go ahead and take a minute to read this question. So this exponential function models the gray wolf population of the northern Rocky Mountains. So we say f of x is x years after 1978. Project its population in the recovery area in 2010. Okay guys, this question seems very complicated, but it's really not bad. Okay, x is x years. So we're talking about from 1978, then we have to project the 2010. So basically our x is 2010 subtract 1978, which give us 32 years. Okay, and then all we have to do is plug in this 32 years in your function. So 1.26 e to the 0.247 and to the multiply 32. Remember, e is going to be around 2.7. It's not a variable. Okay, so you can actually just plug this whole thing inside your calculator, and then you're going to get around 3,412. All right, next is the compound interest. If you can take a minute and then go ahead write this formula down, that would be great. We say the first one is for n compounding per year. So a equal to p multiply 1 plus r over n to the n multiply t power. So each piece you can see where it wrote a is the balance, and then p is the principal, and then we have r is rate, and then n is compounding per year, and then t is years. Then here we have some blue color, that is when we talk about all the n. Maybe I'll just highlight this. Okay, so we have n, we semi-annual, n is equal to 2, quarterly, that is n equals to 4, and the monthly is n equals to 12. Okay, and then we also have a second formula is for continuous compounding. That is just going to be a equals to p times e to the rt power. So we say you decide to invest $8,000 for 6 years, and you have a choice between two accounts. The first pays 7% per year, compounded monthly. The second pays 6.85% per year, compounded continuously. Which is the better investment? Okay, you can pause this video and then try to figure out yourself first, and then maybe make a guess. Okay, so let's look. The first one is compounded monthly. Monthly, we're going to use the first formula. So I'm just going to write down the formula first. Okay, that is a good way to start. Okay, then we're going to look at each piece. Okay, so A is the balance. We're talking about the balance in the end. The P is initial, basically principal, how much you invested it. All right, so that was the initial amount. In this case, initially we had $8,000. That's our investment, right? That is our P. So that's 8,000. And then plug in 1 plus R. We talk about this is the rate. Remember, your R says is 7%. So 7%, we have to change this to decimal. Some people really have a hard time to change this to decimal. Some people always make a mistake. You can just use a calculator. All right, 7 divided by 100 give you 0.07. So that is our R, 0.07. You always have to change to decimal. Okay, the N, we're talking about the compounded monthly. That means our N, we said monthly, that N is 12. Okay, and then we have N to 12, and then T, in this case, We're trying to invest this for 6 years. So once you have this, the rest of stuff, we kind of just simplifying. All right, again, use your calculator to help you. You're going to simplify this. You're going to get $12,106 and then 84 cents. So that is for the first investment account. And then if we're going to put this money for the second account, so this is compounded continuously. So that means we're going to use the second formula. So now we're going to look at what is the end balance for our case. $8,000 start at the same place. E, in this case, our R is 6.85%. That is 0.0685. Okay, that is our rate in this case, 0.0685, and then times the T is the same. That is 6 years. Okay, so once we have this, we set up, and then all you have to do is just plug inside your calculator. So we're gonna have around $12,066.60, and then you should realize our account 1 will make more money. And thank you very much for watching the video. I'll see you guys next time.